Okay, we've saved the best part for last, which involves joins. Join clauses are used to combine data from two or more tables in a SQL query. We indicate the type of join we're doing and the tables we're referencing, and we do this in the middle of our from clause. But to complete this join, we have to specify the two columns that function as a primary key, foreign key pair. In other words, the field that the two tables have in common. And to do this, we use the syntax on. And going forward, we're going to have to use prefixes to identify the precise table and field that we're referencing. The last thing that I'll mention here is that there are a variety of different types of joins. A left join, a right join, a full outer join. And at this stage in the game, I don't really want to get into the weeds with what those mean. For now, we'll be fine just using the syntax join, which refers to an inner join. An inner join will retrieve only those records where there is a matching primary key and foreign key. There's certainly use cases for the other examples I've mentioned, but this one will do for now. And I understand learning how to code these up with words alone is not that helpful, so let's just dive back into some practice together. Number 7 asks us to generate a list of all employees and their work locations, including both a city and state. If we scroll down and look at the data model, we can see that the fields referenced in this question, first and last name, and city and state, these are housed in two separate tables. And that lets us know that we need to perform a join to output all of these in one single query. And before jumping back into dbGate Lite, I want you to take note of what single fields these two tables will have in common. After scanning over it, you should observe that location ID, the primary key of the locations table, is housed as a foreign key in employees, and we'll need to remember that when we construct the join later on. So back in this database, we'll add a new query, and we will select first name, comma last name, comma city, comma state. And we need to select these from both the employees and locations table. So we specify from employees join locations, and we join them on the primary key foreign key pair, the field on which these two tables have a match, and we have to specify it with table prefixes. Employees.locationID equals locations.locationID. And when we run that, we now have a single table with 1,000 results, all 1,000 employees with their names and where they work. Let's save this as question 7. And as a quick note, with all of these previous queries we've done, you can always click on a previous one. They are stored as code, not as data, and you can quickly run this code to get the same output as before. So as a reminder, we're doing this in incognito mode. That was to avoid some issues that are browser specific. But the second that we close this window, all of these queries and the database itself will be discarded. So just be mindful of that as you work on homework or potentially an exam in the future, that you can save separate queries to document your work, but if you're in incognito mode, these will be totally wiped out the moment you close out of the browser. All right, let's move on to question 8, which asks us to calculate the average cost of products in the tennis product line. Let's take a minute to once again look at the data model to see which two tables we need to join. We want the average cost of products in the tennis product line, which we'll only get from the product line name field in the product lines table. So we can see the two fields that are uniquely housed in these tables. And then lastly, we also need to take note of the primary key foreign key pair on which these two tables match, which in this case will be product line ID. So as we whip out a new query here, we can select product line name, comma, I want the average cost, so I will use the AVG function, open parentheses, cost, and we can name this whatever as average cost. In this from clause, we now specify the two tables and the join, but now I'm going to show you another helpful trick that will save you from having to type table names every single time, and it is called using a table alias. So after I type products here, I'm going to type a lowercase p, which means that hereafter, when I invoke the letter P, it will recognize this as referring to the products table. So select these fields from products P, join product lines, and I'll give this one the alias of PL. So now when I specify the primary key foreign key pair, the table prefix I will use is p dot product line ID equals pl dot product line ID. If I run this as is, it is now taking the average cost across all product lines, and it's using the first one that shows up, soccer. That's not right. We need to finish this off with where pl.product line name equals, in single quotes, tennis. So we're now going to go from roughly $68 as an average cost to between $45 and $46. This is now a completed query. Let's save this one as Q8 and move on to our last one. Number 9 is a bit gnarly, I'll admit. It is a comprehensive problem that assesses all three skill sets we've been working on in this practice. We want to know the total sales amount for a particular order whose ID is PO-05001. And then we're told that the sale amount for a given order is equal to price times the quantity of all items sold. So we'll need to sum that up. Again, for a problem like this, I highly recommend going back down to the data model to see where fields are housed and what primary key foreign key pairs we're going to work with. Here we can work with the products and order lines table. I can specify which order ID we're working with to isolate our answer to a particular purchase order, and I can see that when we construct the calculated field of sale amount, it's going to be quantity from order lines multiplied by price in products. And lastly, to join these two tables together, the common field is product ID, the primary key of the products table, and a foreign key in order lines. Now, if you want to pause the video and see if you can do this one on your own, I want you to know that I would be incredibly impressed with your mastery thus far. If it takes you several attempts and you still don't get there, that's totally fine. But sometimes having that initial productive struggle is a valuable learning experience. Now, this solution query is kind of lengthy, so I'm just going to copy and paste it here and explain it one line at a time. And as I walk through this, I'm going to zoom in so you can see it all at once. We are going to be selecting order ID and a calculated field called sale amount, which is set equal to the price of each product in a given PO multiplied by the quantity ordered. And then we're going to take the sum of all of that. These fields are selected from the order lines and products table. But when we join these, we're giving them the table alias of O for order lines and P for products. The primary key foreign key pair that these two tables have in common is product ID. And when I specify that we're joining them on this field, I'm using these table aliases, O for order lines, P for product. And I don't want to do this across all orders. I only want to do this where orderlines.order ID equals, in single quotes, PO-05001. Lastly, I'm grouping this operation by order ID, and it's actually not that important given this where clause, but I think it's best practice just to include that in. So now going back out, we can run this query and see that for this purchase order, the total sales amount was roughly $307. All right, so we covered a lot across these videos, and I want you to pat yourself on the back for making it thus far. If you feel like you need additional practice, I've included links to other online resources in these downloaded materials. But again, congrats on making it this far, and I look forward to seeing you in our live stream session.